Second to last video for day 18. This is a bit of a sort of a side turn interlude, but it's something that I think is worth noting. Um, Up at the beginning, I said our motivation here in the end was to be able to compare two strands of DNA to see how similar they are. Now, we actually don't care about the edits. We only care about the cost of the edits. So it's kind of a shame to have to compute all these edits and then throw them away just to compute a number instead. Can we do both at the same time? That's what normal implementations of Levenstein edit distance do. They do a bunch of other things. If you go to the Wikipedia page, you'll see all kinds of discussion about this matrix representation that allows them to avoid doing any recomputation. It's a very clever approach. It's super cool. I recommend you check it out. It's fun to look at. You'll learn about those techniques later on in CS62, or if not there, in CS140. Let's say data structures or in algorithms, one or the other. But we can do a part of that work here and define a function Levenstein distance that's like Levenstein, except it actually just computes the cost, right? So you'll notice we use min3, not argument 3, and it's just going to return a nat. It says, hey, this is the actual distance between the two. The lower, the better. The lower, the closer they are. Now, a thing you might want to know is that, well, look, it agrees, right? Like if we know Levenstein produces valid edits, is this like the right function? Like, what if I messed up? Right? How do you know? So this theorem, this correctness theorem says, hey, whatever distance Levenstein distance returns, that is actually the total cost of Levenstein. Right? This proof will have a pretty similar structure to what you had above. I think it's a little bit simpler. If you're stuck on Levenstein valid, this might be a good place to sort of find your proof legs for dealing with a let fix enter. Your mileage may vary. I'm really not sure what's going to be best for people. I think people have different ways in here. But I wanted to highlight this for this reason, that I think it's maybe a slightly easier proof, and B, it's a really common technique. Levenstein distance is the function we care about. We actually are going to do a bunch of proofs about a different function, but then we're going to prove something that relates our function that we're going to actually run, Levenstein distance, to this more robust specification with more information, right? So that's a really useful thing. I'll return to this idea when we get back in the next video to talking about Levenstein itself and talk about optimality. That's all I've got for you on this one. One more to go.